Hey guys, let's talk about divergent plate boundaries. All right, what you see here, which you can probably guess, is the ocean. And at the bottom of the ocean floor is hard, solid rock. And we call this the oceanic crust. If we look deeper underneath the oceanic crust, we will find that there's something called the mantle. And the mantle is made up of this Play-Doh-like consistency of rock called magma. It's very similar to lava, but it is under the oceanic crust. The hard, solid rock that's at the bottom of the ocean, underneath that is something called the mantle, which is not hard or solid at all. And it is made out of this magma consistency material. In the center of our Earth is our Earth's core, and it is super duper hot. It is what heats the magma and makes it into this putty-like consistency. And when the material inside the mantle gets heated by the core, it goes from being cold, dense rock to hot, less dense rock. And hot rock rises. So this causes the rock that is here to go up towards the oceanic crust. But when it comes in contact with the oceanic crust, it then cools down. When it cools, it becomes denser, and so this cooling rock sinks until it gets to the core again, where it is heated, and this hot rock rises. This cycle goes on and on and on and forms what's known as a convection current, where we are getting at all times rock that is getting heated and rising up to the top, and then rock that is cooling, getting more dense and sinking to the bottom, where it is then heated by the core. So it becomes less dense and it rises, then it comes in contact with the crust, which makes it cool, so then it sinks, so then it comes to the core and it rises again. So this happens on and on and on, and makes what are known as convection currents. And so when these convection currents are spinning, not only are they moving, but they actually are able to push the oceanic crust in one direction or another, depending on the direction that they are spinning. So if it spins this way, the oceanic crust moves this way. But we don't just get a hole. Instead, our magma rises up and comes out to the surface in the form of lava, and that cools and it makes new oceanic crust. And if both of the convection currents are spinning in opposite ways, it causes both of the oceanic crusts to separate, making even more room for magma to rise up and cool on the surface as lava, and forming new oceanic crust, which eventually creates something called a mid-ocean ridge. So because these are spinning apart, because the hot rock is rising from the center and then the cooling rock is going in this direction, this type of plate boundary here, a space between the plates, is known as a divergent plate boundary. Please let me know if you have any questions now that you have seen this video.